Hey guys, welcome back to the next class of Catalyst Concepts. Uh, Today we are starting a new topic, a new chapter altogether. We're going to look at chapter number 5, and that is Human Eye and the Colorful World. Now, a small part of this chapter would be covered in biology for you, since we know what the human eye is, right? It's one of the main organs of the fifth sense, that is sight. Sight is one of our bodily senses, and sight is only achieved because we have eyes. If we do not have eyes, we cannot see. So going forward, we'll look at how the eye works and what it does. For today, we are going to cover two very simple activities that you can do to find out certain physical aspects about your eye. Okay, so these are some things that you can do at home on your own. So I'm going to demonstrate this for you, but I'd suggest you also try it out on your own, so that you can also prove the same thing about yourself. Also, the findings from this might differ from person to person, so it's a little unique also. So what I get might be different from what you get when you do this activity. Okay, so let us start off with the first activity. So this first activity is to find out something called as least distance of distinct vision. Okay, least distance of distinct vision. It simply means what is the minimum distance needed for you to be able to see something very clearly. Okay, now it's generally standard for a human eye. There's a set value, but it might differ based on like some people who have glasses or some people who don't, and all of that. Right, so for this activity you can do it on your own, but I would suggest try do it with a friend of yours or someone who can help out with the activity. All right, for this you simply need two things. You need something to measure with, something like a scale, a short scale, a long scale, a tape, anything to measure. And you need something that you can see or read. It can be as simple as a piece of paper with some text written, or a book that you read. Generally anything will do. Okay, simple equipment. Now to do this activity, the first thing you're going to do, you're going to take this piece of reading material and you're going to put it like right in front of your face. Okay, like right in front. So I'm going to show it from the side so it's a little clear to you, like this. Okay, now obviously when you have something placed like this, you can't see it. I'm looking at the paper, but I can't really read what is written over here. So what I'm going to do, I'm going to slowly back this piece of paper away from my face. Okay, and as you keep backing it off, things will start to look a little more clear to you, right? The reading is going to be much more clearer. So what the intention is here, you need to back it up until you can read the words clearly without any strain on your eyes. Okay, so sometimes when you have things very clear, you'll see that this part of your face is going to hurt right over here in between the eyes, right? The objective is find at exactly which point you can read it but there is no strain in your eyes. Okay, so I'm slowly backing it up like this. I can even do it from the side. Okay, so this is pretty much like I don't feel any stress, right? Now what you're going to do at that point, you're going to either measure the distance between the eye and the paper on your own, or you're going to ask a friend to do it for you. Either way works. and just use a scale or a measure, and you'll find that distance for you personally, that would be your least distance of distinct vision. Okay, anything closer than that you will not be able to read clearly. Right, so this is a very simple activity. On an average human, the least distance of distinct vision is about 25 centimeters. Okay, so for a normal human eye, 25 centimeters is the minimum distance needed between the eye and the object that you're trying to see. Anything closer than that, you'll not be able to see. There will be some differences based on different people. You just need to find out what is your own, right? Quite a simple activity. I do encourage you to try it out on your own. What you can do, try it out on your own and just drop it in the comment. Just tell me like what was your how much distance you had for distinct vision, like what was your finding for this. Okay, should be interesting. Now let's go ahead with the next experiment. Again, this is also a very simple experiment. You can try out on your own. For this, what you're going to need, you're going to need some long objects. Okay, say this scale is one long object. You can also get a bigger scale or a bigger stick, but just know how long it is. Okay. Now what we are trying to find out here is, initially we looked at distance from the eye to the center of the object, like where you're trying to read, right? Now I'm trying to find out what exactly is the top and the bottom. I need to be able to see the top and the bottom of an object clearly. All right, we can start off in the same way pretty much, and that is by having an object really close to your eyes. Obviously I can't see the top or the bottom of this scale right now, right? I'll need to keep pushing it a little back, while I need to look at the center of the object, but I should be able to see the top and bottom of it. Okay, they should be in focus. That is what this activity is for. All right, now okay, now so this is about the distance at which I can see. Yeah, I can clearly see the top and the bottom of the scale clearly. All right. If I come any closer than this, I cannot see either one. It's like a blur. I can't really tell where is the top and where is the bottom for this scale. I only have to touch and feel and figure out. Otherwise I wouldn't know. Right. Now what is the objective of this is figure out what is the angle over here. All right. So the angle would be something like this. This is perpendicular to my eye, the center of the object. The top comes down to the middle of my eye at an angle, so does the bottom. Why I'm talking about angle is because we know that light has to hit the object, then hit our eye. Only then we are able to see an object, right? So I'm looking at what angle the light coming from this end is making, and the angle this light from this end is coming and making. So if you see it, it is going to be a triangle from here like this and like this. So this is the base of the triangle. These are two sides. I need to know what is this angle from here to here. Alright, if you use a little bit of trigonometry, you can find that out. You know this distance, you know this, so you can make a 90-degree angle, and you can over here 90 degree, it's a right angle triangle. So you can use the base and adjacent and find out the hypotenuse of your triangle. That hypotenuse, if you can find out, this hypotenuse and ultimately figure out what is the angle that the top and the bottom are making with your eye. Okay, you don't need to get into too much mathematics over here, but ultimately the point is, if the object is closer to my eye, the angle made by it is very steep. Okay, observe, the angle is very big, it's a wide angle. But if I make it far, the angle becomes little bit narrow, so it's a bit narrow, right? The angle is smaller the farther it goes, and the closer it comes, the angle is bigger. So you need a certain angle minimum that is needed at which you'll be able to see the ends of the object clearly, basically the whole object from top to bottom. Normally for a human eye, that is 60 degrees. Okay, so the angle, if it is from here to my eye and back here, if this angle is 60 degrees, then I'll be able to see the object clearly. Anything more than 60 degrees, basically meaning if it's more close, angle is bigger, I will not be able to see the top or the bottom clearly. But if it is less than 60, it still works, right? So even if it is like 30 degrees, if I keep it far from me, I can still see the top and the bottom, right? So anything below 60 degrees is working, but it has to be at least 60 or at max 60, I can say, right? Similarly for the distance, if it is 25 centimeters from my eye, I can see the object clearly. More far also I can see, but closer than 25 I will not see. Okay, so two key things to keep in mind. One, the least distance has to be 25 centimeters from my eye. Okay, and the angle has to be at max 60 degrees. If it is bigger than 60, I will not be able to see, and if it is closer than 25 centimeters, I will not be able to see the object either. Okay, very simple activities, you can try them out on your own. I encourage for the first one. Second one might be a little bit tricky, you will need help from one or two more people, but yes, do try it out. And that would be the end of today's class. Two major things we learned: distance, least distance of distinct vision, and the angle of vision. So how much angle is needed to see an object clearly. Alright, so that's it for today. I'm going to see you in the next class. Thank you so much. If you have any doubts, please drop them in the comments, and I'm going to see you in the next class. Bye bye.